Hello again, welcome to Maths is Not a Mystery. We are doing the second of our Surds videos today, and this is all about rationalising surds. Now, first of all, let's make it quite clear what rationalising means. The surd fraction that you can see there in front of you, 3 over the square root of 11, is something that is absolutely abhorrent to most mathematicians. Having a root on the bottom of a fraction makes it really very difficult to understand, because what this means is 3 divided by this number with an endless decimal. It's impossible to divide 3 by something that's got an endless decimal. This is an irrational number. Most square roots, apart from the very obvious ones like the square root of 4 and the square root of 9 and so on, most square roots are irrational. They just go on and on and on forever with their decimals. And what rationalising a surd means is to get rid of that square root on the bottom. Now, how do you do that? Well, let's just think about something for a minute. If I can just take you over to this side of the page, and if I could get you to think about a different number rather than the square root of 11, if I got you to think about the square root of 9, and we multiplied it by the square root of 9, think about what that means. We know what the square root of 9 is. The square root of 9 is 3 times 3, which equals 9. So the square root of 9 multiplied by the square root of 9 actually equals 9. Now that's a very important thing. You can remember it with numbers like this because you can figure out what the square root actually is. With other numbers like the square root of 7 or 11 or 15 and so on, where you don't know what the square root of it is, the true answer is still the same. The square root of 11 times the square root of 11 is 11. Now, with that in mind, all we have to do is we have to multiply our entire fraction by the square root of 11. So we're going to do 3 over the square root of 11, as we had there, times by the square root of 11 over the square root of 11. If we do that, 3 lots of the square root of 11 looks like this, and the square root of 11 multiplied by the square root of 11 is 11. And now we've rationalised it. We've rationalised it because on the bottom of our fraction now, we don't have a square root. We have a real number, a rational number, which is why we've rationalised it. Realistically, it doesn't make life much easier for us, because what it's now saying to us, instead of 3 divided by this weird number, the square root of 11, you've now got a different weird number, 3 lots of the square root of 11, but it's been divided by a real number, by 11. And somehow that seems to make most mathematicians much happier, because they're dividing by something that you can actually divide by. So that's what rationalising is. Now, unfortunately, most of the questions that you're going to see on an exam paper are not going to be as simple as doing this. You might be very lucky and get one like that. In all honesty, what you're going to get is something that's a little bit harder. So we're now going to look at applying the rationalisation to a harder question. Now here's a question that says 5 divided by 3 plus the square root of 2. Now, what we've got to do is a number of things here. First of all, we've got to get rid of that square root at the bottom. We have to get rid of the square root at the bottom. But because we've got a plus sign in here, if we just multiply everything by all of this, we're not going to have the answer that we're aiming for. So there's a particular rule in Surds. And what we do when we're solving a question like this is we multiply everything by precisely what's on this bottom of the fraction, except that we change the sign. That sign is a plus, and we change it to a minus. If that sign was a minus, we would change it to a plus. And so we're going to multiply the top line of the fraction by 3 minus the square root of 2. And we're going to multiply the bottom line of the fraction by the same thing, 3 minus the square root of 2. And by doing that, we're going to have to create quite a complicated little calculation. Let's have a look how we do it. Doing the top line, 5 times 3 minus the square root of 2, we need to think about doing it in bracket form. Think about brackets, 5 lots of 3 minus the square root of 2. Now if you expand those brackets, 5 times 3 makes 15. 5 times minus the square root of 2 equals minus 5 lots of the square root of 2. Now that's already now sorted out the top line of our fraction. Now let's just keep that in mind for a moment. We're going to need it later. But let's look at the bottom line now. We've got to multiply 3 plus the square root of 2 times 3 minus the square root of 2. Now again, we're going to do this in bracket form. We're going to expand brackets, but this time it will be a double bracket. So we're going to use the FOIL method, if you remember that from before. First, outside, inside, last. So the first ones, the first of each bracket, 3 times 3, nice and simple, is 9. The outside ones, now that's going to be 3 times minus the square root of 2. And what that's going to be is simply minus 3 lots of the square root of 2. That's what it says it is, isn't it? 3 lots of minus the square root of 2. So that's nice and straightforward. The inside ones are going to be the square root of 2 times 3. So those two there. The square root of 2 times 3 is going to be 3 lots of the square root of 2. And the last, that's going to be square root of 2 times minus the square root of 2. Now remember what we said before. If this was both plus ones, the root of 2 times the root of 2 would be 2. If it's the root of 2 times minus the root of 2, then it's going to be minus 2. It's the same rule, just with a minus on it. So what we need to do now is we need to put all these things together. So our answers are 9 minus 3 lots of the root of 2 plus 3 lots of the root of 2 minus 2. Those two things in the middle cancel themselves out. Minus 3 lots of the root of 2 plus 3 lots of the root of 2 takes you back to 0. So we can simplify that to 9 minus 2 because these bits have gone completely. All we've got are the numbers on the outside. Now you remember we had to keep this because that was the numerator of the question. That was where we'd solved the question of 5 times 3 lots of the square root of 2. So that's going on the top of our fraction now, 15 minus 5 lots of the root of 2. And on the bottom of our fraction is going this next section here. Obviously we can simplify that a tiny bit more simply by doing this. Okay, 9 minus 2 is 7. We've ended up now with a rational number on the bottom of our fraction. So we've rationalised it and we've also sorted out the entire calculation. Okay, that's it. That's it completely. And there we are. That's how you do one of these kind of fairly complicated rationalisation questions. All you do, let's just recap, is you multiply both top and bottom by whatever's on the bottom of your fraction, but you swap the sign. Plus goes to minus, minus goes to plus. That then allows us to have this combination of two almost identical elements where one is a minus and the other one is a plus, which means that when we've expanded the bracket and we put them into our first answer, they cancel each other out completely. They will always end up as nothing. If they don't, you've done something wrong. It's a good little clue that you've done something wrong. So it means that you're left with your first answer and your last answer. So there we go. That's rationalising Surds. Look in the book. We've got Maths is Not a Mystery Surds book, which gives you much more practice than we can give in a short video. Lots of practice questions and lots of explanations. For now, I hope that's been helpful. Please like and subscribe it if you've enjoyed it, and we'll see you soon on Maths is Not a Mystery. Goodbye.